Hi and good morning everyone. We have done with our report and today we will be going to present our topic which is photoelectric effect. My name is Muhammad Haiqal bin Abu Bakar. My meeting number is 197447. And I have another two group members that will present later. So I will start with introduction first. The photoelectric effect was discovered in 1887 by German physicist Henry Rudolf Hertz. This relation between light and electricity was clarified in 1902 by another German physicist, Philip Lenard. Albert Einstein formulated in 1905 a new corpuscular theory of light in which each particle of light or photon contains a fixed amount of energy or quantum that depends on the light frequency. Okay, so for the theory part, the photoelectric effect is the emission of electrons or other free carriers when light hits a material. The photoelectric effect can be attributed to the transfer of energy from the light to an electron. From this perspective, an alteration in the intensity of light induce changes in the kinetic energy of the electrons emit from the metal. Emission of conduction electrons from typical metals usually requires a few electron volts corresponding to short wavelength visible or ultraviolet light. So next I will pass to my group members, Elmira, Melissa.
Okay, hi. I'm Elmira Melissa Hilmi Rizal. My matrix number is 197055. So today, I'll be presenting about the advantages and disadvantages of photoelectric effect. The first advantages is that photoelectric effect empowered power solar. Sorry. The first advantages is that photoelectric effect empowered power solar. So only a couple of cells are needed to power small electronics. This is important because power solar helps in the economic growth, where it is more cheap than the oil. Photovoltaic cells made from semiconductor-grade silicon quickly became the power source of choice for use on satellites. So the next advantage is that gold leaf electroscope is an important tool in illustrating the photoelectric effect. So these electroscopes are designed to detect static electricity. The stem and the gold leaf have the same charge, hence they repel each other. So if the electromagnetic radiation does not have enough frequency, the leaf will never discharge, hence there is no static electricity. Static electricity is important because it is used in pollution control by applying a static charge to dirt particles in the air, and it is then used to collect those charged particles. The third advantage is that it is used in photoelectron spectroscopy. Since the electrons will be scattered by the air, this electroscopy is done in a high vacuum environment. So these electrons that are created will then show up as spikes. It can be used to determine the elemental composition of the samples. So I'll proceed to the disadvantages of photoelectric effect. The first one is that photoelectric effect contain beams that can be blocked by outer factors such as dust, steam, moving machinery, smoke, or even human apparatus depending on their frequency, brightness, sensitivity, and placement. Their performance can also be affected by the variations in their power supply and also weather conditions such as rain, fog, dust, and snow. The next disadvantages is that photoelectric effect create non-constant control with photoelectric switches. So periodical fluctuations are considered to happen. A desired limitation of the deviations from the theoretical value is not obtained with this fluctuation. For example, it may be mentioned that changes in the actual value are converted by a system comprising a galvanometer, spot of light and photoelectric cell into voltaic fluctuations on a photocell. This is a disadvantage because tyrotons are very expensive. So the last disadvantages of photoelectric effect is that it has impact on the spacecraft. It brings undesirable impact. Net positive charge is built up on the exterior of the spaceship. When it is exposed to sunlight for a certain period of time, it will lead to continuous emission of electrons from the metallic surface. Hence, the site in shadows will develop a relative negative charge. This is a bad idea, especially when we have to delicate circuitry and machinery operating inside the ship. So, I will move on to the application of photoelectric effect. The first one is night vision devices. So, this is the night vision devices where here is the electron, photocathode, and object is placed right over here, and this is the phosphorescent screen. Ooh, sorry. Okay. So, night vision devices is an application of photoelectric effect. So, when photons enter the device and it strike the plate, so it enter the device and it strike the plate, it causes electrons over here to be emitted. This electron will then pass through a disc containing millions of channels. When the electrons hit a fluorescent screen, or we known as phosphorescent screen over here, electrons hit it, current which flow through it will be amplified and directed to its screen and it will glow. Okay. The next application of photoelectric effect is the X-ray photoelectron spectroscopy. So as you can see, this is the X-ray photoelectron spectroscopy. So image converter, image intensifier, television camera tubes and image storage tubes are also the examples of photoelectron application that use point-by-point emission of the photocathode. In these devices, light image is transformed into an electron image. So, electron optical device is used to focus the electrons that are released by each element of the photoemitter into the fluorescent screen. So, X-ray photoelectron spectroscopy, it is a surface-sensitive quantitative spectroscopic technique that measures the elemental composition at the parts per thousand range. So what this thing does is that it reveals the internal structure of objects determined by variations in density and atomic composition. So X-ray is used to measure the kinetic energies of the emitted electrons and irradiate the surface. So the next uses of application of photoelectric effect is that it is used in fire alarm. So alarm can be set off by the use of photoelectric effect. There is a photoelectric smoke detectors that can block a light beam. A detector named T-shaped chamber contain LED, light emitting diode. So there is a photocell that is positioned at the bottom of the vertical base of the T, which generates a current that shoots a beam of light across the horizontal bar. So when sufficient light hits the cell, the current will then trigger the alarm and the alarm will be set off. I will pass to my other members.
Okay, Assalamualaikum. Hi, my name is Afiza Binti Azman. My metric number is 198531. So, in conclusion, electromagnetic radiation can emit electrons from the surface of a solid that called as photoelectric effect. Electrons ejected by photoelectric effect are called photoelectrons. There are many experiments and observation were made to prove this phenomenon, and this photoelectric effect is the beginning of modern physics. The maximum of the photoelectric effect is directly proportional to intensity. If the frequency of the incident light is less than the threshold frequency, then no electron ejected. The maximum kinetic energy of the electron depend on the frequency of the incident light. There is no time lag as the electron emitted immediately. So the maximum of kinetic energy of photoelectron can be determined by measuring the stopping potential. The Ke of photoelectrons increases linearly with the frequency of the incident light. The kinetic energy of photoelectrons is directly proportional to frequency of light, and the stopping potential is directly proportional to the frequency. So on a graph of maximum kinetic energy and frequency, all curve and linear, and the slope is the Planck constant. So from the discovery, there are many applications that have been made from this photoelectric effect and help us especially in our daily life. So that's all from us.
Okay, thank you.
Thank you.